Of Motion Picture Arts and Sciences, I'd like to welcome you to the Steven Spielberg Family Gallery at the Academy Museum of Motion Pictures and our presentation on the Dykstraflex. So as you saw from this video, this camera was created to film the visual effects in Star Wars, but in reality what wound up happening, unintentional, it actually revolutionized filmmaking. Not just for Star Wars, not just for visual effects, but sort of filmmaking in general. It allowed people to realize the possibilities that things that they could do with visual effects that they couldn't do before. And that sort of opened up the floodgates to a whole new type of visual filmmaking and visual storytelling that involved sort of dynamic camera moves and spectacular space battles and all of that. And it really sort of launched a new era in filmmaking. And it started out because George Lucas, they say it starts with the script. It's not on the page, it's not on the screen. And he imagined all of these wonderful space battles, and he realized, saw that, it's like, I don't know how we're going to do it. And he was right. Back in 1975, when he started working on this, sort of the standard way of doing things, and it had been this way for quite some time, was, you would come into a stage, you would have a cyclorama, some type of backdrop. It could be clouds, it could be sky, it could be stars. And you would have some tracks in the ceiling, and you would have a model dangling from a wire, and you'd have some old guy, smoking a cigarette, come out, light the sparklers on fire, and the sparks from the sparklers would go down, the smoke would go up, the model would move, it would wobble, and everybody would say, wow, that looks great. And it did in 1930s, 1940s for the old serials and stuff like that, which inspired George Lucas. It worked. People used their imagination. But by the 1970s, audiences were more sophisticated. George Lucas had a documentary background. He wanted people to feel as if there was a dude in a spacesuit out there filming this stuff. He didn't want you thinking, oh, that's a wobbly looking spaceship, because that takes you out of the movie. You want to follow this along. You've been following it along for 90 minutes. Last 10 minutes, you got to be there. So they wanted to come up with a new way to film these visual effects. And they realized a couple of things, past experience. First off, he gathered a team. John Dykstra, Richard Edlund, Don Trumbull, Richard Alexander, Alva J. Miller, Jerry Jeffress, Jamie Short, all sort of worked together. They sort of came together, they formed the core group to develop this, and they said, okay, what have our past experiences been? Because the idea of trying to make things look fluid and make things look realistic wasn't a new thing. It was just sort of the latest progression. It's like, okay, what have we done in the past? Well, John Dykstra and Jerry Jeffress and Alva Miller were at Berkeley. And at Berkeley, they developed a camera system that could repeat movements. It could move that way a certain length, and it could move back the exact same length, and then move forward the same length, and go back and forth and back and forth. Don Trumbull's had worked with his son Doug on silent running, with a whole bunch of other different camera techniques. Doug had worked on 2001, where they had cameras on worm gears, which are these really long, precise things where the cameras just sort of move. Wasn't really controlled by anything except by a little tick mark on the edge of the track that said stop here. Richard Edlund had worked in commercials for Robert Abel and Associates, and they had their own version of it. Everybody had their own versions of this, and it was usually done for a commercial, for a movie, for a TV show, for whatever. And then when it was done, they took the camera apart and they went off and they did something else. So there was really no technology, there was no standard technology. So they all came together, they said, okay, I needed to do this, I needed to do that, hey, I have this experience. And so they said, well, what do we need this thing to do? And they said, well, first off, it needs to have very precise, very controlled movements that can repeat. And we'll get to some of the reasons why it needs to repeat in a second. It needs to be able to film something with motion blur. Now, what is motion blur? Motion blur is the little cue that triggers in your brain that makes you think something is moving fast. Okay? So if you were to pause any one of these spaceship shots, you would see that it's blurry on the edges, on the trailing edges of the wings, and that's what tells your brain that something is moving fast. If you've ever watched any of the Ray Harryhausen movies where the skeletons come out to battle Jason and they look kind of stiff and posed, that's because there's no motion blur. And they realized very early on that they needed to have that feature to sell the sense of speed. And so what they did is they developed, started working on this, and they realized in order to control the motion of this, this thing weighs 1,500 pounds, and a lot of that's up here on the crane. There's 400 pounds worth of crane weights here to keep all this thing balanced. And it's run by these relatively small motors. And these motors are very special. They're more like industrial robot type motors. They're called stepper motors. And as John said, they go, they just go one step at a time. So if there's a revolution, on this little axle here, and in one complete revolution may be broken up into 100 different steps, 100 different pulses of electricity that is fed to this motor by this thing, or in our case, by that thing, which is a far more efficient way than this thing. Anyway, it'll deliver these pulses and it'll make a revolution. Let's say one revolution equals 1 inch of travel along this track. That means that it takes 100 pulses, and they can be slow pulses or they can be fast, and it'll go slower or faster, but it'll only move 1 inch on those 100 pulses. So 1 inch, 100 pulses, 12 inches, 1,200 pulses, 14 feet, 16,800 pulses. Okay, and so it's it's just math. It's counting those pulses, and they can be done fast, they can be done slow, and you can vary the speed. So Les Bernstein here is going to be our driver, and we're going to start demonstrating some of the movement. And first thing you'll notice is that it's swinging. This is sort of our pivot or our azimuth. You can see that the motors are spinning, chain drives. It's now booming down. This crane, this dolly will travel along the track. It's moving very slowly. That's not going to concern us right yet because it's going to be filming at a very slow rate. This here is the camera. This is a custom-built camera, VistaVision camera. You'll notice that it's not sitting on a tripod. It's not sitting on, if you went up to the Godfather exhibit, there's a camera sitting on a dolly. It's got wheels. It looks big. It looks heavy. It is. Well, this is hanging down. We call this the Trojan head for a reason, because it kind of looks like the helmets of the Trojan legions. But one of the reasons why it's hanging down is because it allows us to go down and close to the model. It allows us to go into the trench and skim along the surface of it because there's nothing here. So they've got the clearance. But this has its own set of controls. This thing will pan around, this thing will tilt, this will roll. And again, it is because these motors are stepper motors. Let's just say that this thing moved 100 pulses that way. Well, it's now moving 100 pulses this way, and it's going back to the same point. So it will do that all day long to the exact same point. Sort of. It's 50 years old. It's a bit creaky. So are my knees, but that's what age does to this stuff. Anyway, so that's the camera system. This is the model mover. So again, think of this as a system. There's a control device. Starts off with this jog box. There's a camera, crane. Now there's the model mover. The model is actually moving independently of the camera. And when it came down to doing these moves, they had to sort of break down what the motions are. So for instance, the shot where the X-Wings are flying at camera, there's a formation of them, and they start peeling off and diving. So that motion would be accomplished the X-wings coming towards the camera would actually be accomplished by the camera coming closer to the model. When we replace the background, that motion is going to make it look like the model is coming towards the camera. When it's rolling, starting its roll, that's accomplished by this axis, the roll axis on this, starting to roll and pivot. In order to make it look like it's diving, because the model is fixed in place, the camera does all the motion. So the camera is actually booming up. And as the camera booms up, the model moves down in frame. And again, when you replace the background, it looks like it's doing a roll and a dive. And it would be programmed. What they would do to program all of this stuff is, and you saw it a little bit in the video if you were here, they would take this plate off and they would attach what we call a bore sight. It's really just sort of a tube and what you would look through in order to see through the lens, which is over here. And they would plot out the different axes of movement. First, the usual easy way to do it is to sort of plot the gross movement where the camera is, for instance, zooming in on the model. And then they would look at it and it's like, okay, we need to have it at a certain point roll and start to pitch over. And so they would program that as a separate pass at some point on the timeline. Then the camera had to boom up so that it could dive. They would do that while looking, and literally they're walking along with this thing, and you know, this thing is not going to move. If you hit your head, guess what's going to lose? Your head. So a lot of times people would get concussions from that. Anyway, all of that is a series of numbers. Like I said, pulses. It records, like I said, 16,800 pulses along the length of the track. Well, maybe at pulse number 5,000, this thing has to start rolling. And then maybe at pulse number 6,000, it has to start diving, and something else has to happen. So there's this timeline of all these different numbers that have to happen, and they all have to be synchronized to the length of the shot. And in order to do that, in order to store all of that information, we turn to the icebox. Now, this icebox has all these different little labels for track, pan, tilt, east, west, north, south, roll. And that's where the information could be stored and saved. Additionally, there's capacitors in here that provide electricity to these motors. Anyway, the memory storage system, just to give you some context, we can't unfortunately open up the back, but if you could look in there, you would see essentially this. You know, these are old-fashioned memory boards. This is all hand-wired. There's tons of tiny little pins. It looks like, you know, if you pick it up wrong, it's like getting attacked by a porcupine. But it's, you know, someone who had the skill of a jeweler wrapping each one of these posts with wire. And this forms the memory. And this board has about as much memory as my watch, except that I'm wearing a Timex, and it's not digital. Not very much memory storage, but it was enough. It was not rendering out images. It was not doing a whole lot of heavy computations. It was just remembering the numbers and feeding it back to these devices so that it could move. In order for it, you know, there's some memory in here, but in order to try and save the move, in case they needed to come back to it, again, for repeatability's sake, they could store it on data tapes. And these are, you know, when they talk about the data tapes in Star Wars, well, this is a data tape from Star Wars. This is a trench run data tape. And theoretically, it would play back all the different axes of movement on a device like this. And they would put one in here, they would write it out, and then if they wanted to, they could put it in here and they could play it back. Now, the machine that controlled the Dykstraflex for Star Wars no longer exists. Thankfully, we're fortunate enough to have this. This was made for close encounters. This was made by the same guys, Alva J. Miller and Jerry Jeffress, who worked on the Dykstraflex. They actually built this one first. And for their efforts, they received a Science and Technical Achievement Academy Award. And it's sophisticated in its time. The funny thing is, you'll see that it says Jaws and Jaws 2 on here, and you may think, oh, Steven Spielberg directed Jaws, now working on Close Encounters. Maybe it has something to do with that. No, they put the name on there after the thing started eating the tapes. So there's a limited amount of memory on this thing. And so what they had to do is they had to make darn sure they got everything they needed on the day of filming, because they could store it on the tape, but maybe it would come back, or maybe it would get eaten. Anyways, once they were done pushing all the buttons and recording everything, and they had the lights set up to film the models, came time to push the button. So what this is doing, it's now returning to what we have programmed as the start position for our little demonstration movie. And what it's going to do, we hope, again, it's 50 years old. We kind of set it on fire earlier in the week. They blew out some electronic components. It was glorious. Not. There we go, it's starting to move in. So it's moving really slow. How fast is it moving?
4 frames a second.
This is Les Bernstein, everyone. He's our operator today. So it's moving at 4 frames per second. Well, when we're done filming it and we play it back, and since we can't get the film developed, all I did was tape my iPhone to the front of it. You will see that it's moving kind of what it looks like as we're moving in on it, except this is moving at the real time. It needs to be sped up 6 times. So there we are, we're going in closer, and now we can get close to the model because we don't have all this gack underneath. We don't have the tripod, we don't have, the stand or anything like that. We can get in close, we can get in real close. We're not getting in too close because, like I said, this thing's kind of old, we don't want to damage the model. But sometimes, yes, it would plow into the model. Now, so there's the end of one move. So we've just filmed the beauty pass. So the exposure, with all this light, that's one exposure. Well, if you notice, there's little lights in the cockpit. Those might have to be exposed at a different exposure. Instead of, you said 4 frames a second?
Yes,
okay.
Say 1.
Okay, so let's say 1 second, 1 frame per second. So you'll see that it now will go back, and it can film the exact same move at 1 frame per second, which means that it's exposing for these lights. These lights will register. And because it went back to the same point and went forward again, they should theoretically register. That way it'll look like it was all filmed at once we get it done, get it back from the optical department. In order to double check that this thing is actually going back and forth and back and forth in perfect registry, we have a very sophisticated way of checking that. And that is a little zip tie right here that points to a piece of tape with a little dot on it. And then we have a piece of tape here that's kind of like an arrow. And there's another piece of tape with a black Sharpie mark. And if we're lucky, they move back and, where's the mark? Oh, there's the mark. All right,
Yeah,
mark's
we're
back.
not
We're not back there. Okay, sorry. That's a different one. Say again? Yes, and then so we're kind of limited by the space we have here. If we had wanted to, the Millennium Falcon's on a fixed stand, but if the Millennium Falcon was on a model mover a little bit beefier than this, or we were filming the X-Wing, yeah, they would work in conjunction with each other. Is it lined up?
It is now.
It is now. It's kind of like that. Anyway, it moves slowly. This is just one part of it. After all the film is done, it has to be taken into optical, it has to go through the optical compositing process, where the backgrounds are put in, where the other ships were put in. But the efficiency with this meant that they could film multiple models at a time, or they could film multiple models, back to back to back, and film them as separate elements, and then combine them later. But it made it very efficient. The model was generally stationary, so that they could just set up lights, and they wouldn't have to change the lights every time they filmed it, because in space there's a key light and there's a little bit of fill. Well, or use fewer lights. So anyway, the technology, yeah, it kind of looks old and clunky and a little bit quaint, but it really launched a revolution, and it's still relevant today. The computers have gotten more sophisticated. We've gone from this and a jog box, which was very hard to program, to a little desktop laptop that can be programmed, and it can also make it do more things. We can, with modern CGI and modern visual effects, we can take the data that's coming off of these camera moves, and then we can then hand that off to the CGI artists, and they can put in the monsters, they can put in the spaceships, they can put in the particle simulations and all of that other stuff, and it'll track properly with the elements that they have filmed. So it's still a very relevant technology to this day, and it all got kicked off with Star Wars. Alrighty, any questions?
One question.
Okay, yeah.
I might have missed it, but is the name someone's last name? Dr.
Yes, okay, so Dykstraflex, where did it come from? So yes, John Dykstra was the visual effects supervisor on Star Wars. And he and a lot of the guys that had worked on Star Wars had previously worked for a guy named Doug Trumbull. Doug Trumbull worked on 2001. He had his own effects company, and he had a habit, because he was good at promoting himself, putting his name on it. He made sure his name got out there so people knew who did this stuff. And he had a camera system called the Trumbullflex. And so when it came time to do this one for Star Wars, some of those guys said, hey, you should call it the Dykstraflex, since now you're in charge. And John, various stories will say, yeah, ha ha ha, maybe maybe not. Anyway, it stuck. It was sort of an in-joke, and it has stuck. But the term is motion control camera system. Yeah, that is a good question. Anything else? Oh, yeah.
So when they did like 5 relative ships,
Yes.
was that a whole bunch of ships on those stamps at the same time, or was it?
So multiple ships. So sometimes, okay, for instance, we found this out last year, looking very, frame by frame. So one of the Rebel fleet shots, it's actually, there's a diagram that appears in the video. You'll see that the ships are arranged in groups, and those groups are just mirrored back to each other, or not mirrored, but they're just sort of offset. Same with all of the X-Wings that I described, where they peel off and dive. Well, guess what? It's all the same ship. So what they did is they programmed in a move, then they backed the camera up to the beginning point. They offset it a little bit, tweaked the move a little bit so they didn't look completely the same, shot the same model a second time. Then they backed the camera up, offset the move, tweaked it a little bit so it looked a little bit different, shot that one. And then when they combined it all, it looked like they had three ships in the frame. And it was a very efficient way of shooting it. They didn't have to swap out the models. They shot in the space of an afternoon, because they didn't have to build 3 models. Yeah, and I mean, they had other models, but it was just easier to shoot it that way. They didn't think that anybody would be sitting there with a Blu-ray going frame by frame. They didn't think about me, back then. Yes, sir.
Gene,
Yeah.
explain how you would look at a move once you shot it, because it was before video.
Okay.
Yeah.
Right. Okay. So. Pat McClung here is a veteran of all of this stuff, has loaded the question, stacked the deck kind of. So how would you look at it? So there was no previs, there was no video tap or anything like that. So if you wanted to check the move before you set up all the lights and expose the film and send it to the lab, and then the next day, we messed it up, it's not good. What they would do is they would load the camera with black and white film, and just the special kind, RAR, rapid access.
Yeah, it was a military.
It was a military thing. It was black and white film. That's all you need to know. And it was the kind of film, black and white film, that if any of you in high school or college took a photography class, you know that you can develop black and white film in a relatively simple lab. Well, they had one of those little labs and then one of those machines on site, so they could load it with black and white film, shoot the pass, then they could shoot the pass with the TIE fighter, the pass with the X-Wings, and they could develop it on site, and then they could take it over to another machine called a Moviola, which allows them to load it up, stack the different pieces of film, they could run it through, and they could see how things were working, and they go, yeah, we got it. Or they could say, nope, we need to go back, and halfway through, it needs to zig instead of zag, and then once they finally got it to the point where it's like, yep, that's working, they could load it with the expensive film, the color film, and they could film the pass. Yeah, you right there.
Thanks. Is there just one set speed for?
There's not one set speed. It can run at various. It's all variable to what the Dykstraflex can stand these days. Sometimes they would shoot it very slowly. Sometimes it would move faster. We're trying to make sure we don't break this again, so we're moving it very slowly. There are some modern motion control rigs that will move very quickly, and they are literally industrial robots that are used to make cars that they are using now to put cameras on and put other pieces on. So yeah, it could move at different rates.
I was just asking because you had mentioned earlier about a shot needing to be sped up 6 times
Sure.
in order to get that effect. So how would you determine how many times to?
Well, the idea is the shot was a predetermined length. Okay, let's say it was 2 seconds long. That's 48 frames. Okay, so you know that whatever move you have to do it in 48 frames. You may be filming it at 1 frame per second, but when you're playing it back at 24 frames per second, you're going to see it at the natural speed. It kind of doesn't matter how fast you film it when you're working with a camera like this, because you've got your exposure adjusted for the 1 frame per second. It's going to expose it beautifully, and then it's going to be played back at 24 frames per second, and you'll see the natural, the motion blur. You'll see what the natural movement is.
The camera, when the moves are written, the camera is locked into all the other axes that move as well. So you can go at 6 frames per second and the camera will roll at 6. You could go at half a frame per second and the camera will be at half a frame. So they all match up frame by frame. So you can shoot 5 passes and they all will be exactly the same position.
What's your question?
Was it a program that they originally created, or did they use a specific program to input the?
No, they invented it later on, after Star Wars and after Close Encounters, the sort of first generation of motion control photography. A guy by the name of Bill Tondreau developed software that actually allowed you, instead of having to do it, not because the controller was literally a knob for each axis. And if you turned it clockwise, it moved it forward, and the more you turned it, the faster it went. Moved it backwards, moved it to anti-clockwise, it would back up. And you were literally just recording the move. Someone would say, okay, rolling, and they would push the button, and then they would do the move, and then they would hit stop, on it.
Yeah, and what they would do with that method, you do that, say, with the track, then you play back the track, and you do the same thing with, say, the swing.
Yeah, swing,
Until that looks right.
elevation, until
And
you
you play
build
back.
the move.
Then you go back and you play back track and swing, and you build the boom. And you kind of build your move that way.
So was
This
it
is the second.
precision?
Yeah, it was precision. Yeah, it was precision because the camera's not really moving that fast. The second generation of motion control was more based what you see there on the monitor. It's like, okay, so there's a representation. All of those horizontal lines represent different axes of movement. The vertical lines represents the rate, the position, the start, and the stop. And they could actually go in and you know, the breakthrough thing is like, oh, we can plot the curve. You know, we have all these numbers, we can show it on a graph, and then we can smooth it out. So instead of, you know, something that's like, you know, herky jerky, they could smooth it. They could ease into the move, or they could ease out of the move, and that was considered, you know, revolutionary as well. And it was built into this.
Yeah, it's more actual programming.
Yeah.
The other was sort of like recording,
Gotcha.
which you can also do with this. You could also
Yeah.
set up, I mean, I've done moves where I programmed it with keyframes, and then some other axis, I'll actually use the encoder
Yeah.
and kind of record it to make it feel more natural or more like live action, for example. And it's frame accurate.
Yeah. Yeah.
Thank you.